Hello, my name is Ben and I'm bringing you a video today on how to configure a full mesh VPN setup between multiple VPCs in multiple geographic regions. We're going to be using Openswan as our software VPN solution, and we're going to install this on a NAT instance so that we can take advantage of both VPN access as well as provide access to the outside world for our private EC2 instances. Now, before I get started, let me just say that this video was created on the assumption that you understand some basic EC2 and VPC concepts. VPC stands for Virtual Private Cloud and is the equivalent of having a virtual data center in the cloud. You can assign it a network CIDR, private subnets, ACLs, and utilize many other features that you would see in a traditional data center. If you've never used a VPC before, I would suggest that you read over the official AWS documentation, and I'll provide the links to that in the description of this video. Now onto the network topology here. As you can see, we've got 4 different regions with 4 different VPN gateways. Each of these gateways will have their own unique connection to every other region involved, hence creating this full mesh topology. Now these VPN gateways are actually installed on Linux servers, which will also turn into NAT servers as well. The NAT server will provide the back-end servers, which are in a private subnet. It'll provide them with access to the outside world or out to the internet. This is important if your back-end instances need to have access to the outside world for updates or to push data to things like S3. But you don't want anybody to actually access them directly from the outside in. Alright, so we'll go ahead and get started building this. I'm in my AWS console right now, and the first thing we need to do is create a VPC if we haven't already have one. And I'm in North Virginia for this. By the way, I was going to tell you that due to time constraints in this video, I'm not going to configure all 4 regions. That would just simply take too much time to do. I've already pre-configured 3 of these regions, and we're going to work on the Virginia region right now. So once this configuration is done, you'll see that the IPSEC tunnels they should just come right up. And you just take that concept and replicate it across all of your regions there. So I've already got a VPC created. If you don't have one created, you just click the Create VPC button, or it should be here in the middle of the screen if you've never created one before. It's going to ask you what CIDR you want to use for this region. For my region, I put 10.255.0.0/16. We're going to break this up into 2 subnets. One subnet's going to be a private subnet, one subnet's going to be a public subnet. So to do that, just click on Subnets, Create Subnet, specify the VPC you're working in, CIDR block. For our private subnet, oops, wrong prefix. There we go, 10.255.0.0/24. This is going to be our private subnet. It's a /24. Going to create another subnet. This one's going to be our public subnet for our VPN server. So we're going to make this one 10.255.1.0/24. One other thing, you'll notice that I'm moving through this kind of quickly. Just feel free to pause the video at any point. We've got a lot of information to cover in a short period of time, so that's why I'm kind of moving through this quickly. Okay, so we've created our 2 subnets, one public, one private, and now we need to look at our security groups. Security groups, again, they're more like firewalls than anything else, like stateful firewalls. We're going to create one security group for our front-end VPN server, so VPN front-end. Notice I'm giving it a tag name that I'll recognize and can easily pick out. I would suggest doing the same in your case. Going to select the VPC ID you just created. Hit Yes, Create. Create a second security group. We're going to call this one VPN Backend. Same thing, choose the same VPC ID, create it. Now right off the bat, we're going to go ahead and make some modifications to the rules here. We're going to allow traffic to speak back and forth between these 2 security groups. The best way to do that is to specify the security group IDs as the source in your roles rather than using like an IP range. It's just more efficient. So let me show you what I'm talking about here. Right now we're looking at the details of VPN front end. I'm going to copy the security group ID of the VPN front end security group. Then I'm going over to the VPN backend, inbound rules, and now I can specify the VPN front end security group ID as the source for this rule. I'm going to allow all traffic from it, and then add rule. Click apply rule changes. Going to the details tab now of VPN backend, I'm going to copy its security group ID. And we're going to the VPN front end inbound rules, specifying it as the source, allowing all traffic from it. So right off the bat, we allow open communication back and forth between these two security groups. Now we're still looking at the VPN front end. We need to add a few rules to it first. The main thing is we need to allow the public IPs of all the VPN gateways of the other regions that we're trying to connect to. So let's go ahead and do that. I've actually got this in a notepad. Again, I would recommend you do this too. There's a lot of information, so I take notes on every step of the way that I go here, and just consolidate all this information in one place. For example, I've got the region, the CIDR of that region, the public IP of that region, and then the private internal IP of the VPN server. You'll see why you want to have this all consolidated in one area. But anyways, we'll continue here. We want to allow Sydney, the public IP of Sydney in this rule. And you can lock it down to specific ports if you want to, but I'm just going to allow all traffic for the purpose of this test. Oh, wrong page here. Next, we're going to allow Ireland. Now, obviously, the information is going to be different in your case. I'm just showing you the concept behind setting up a full mesh VPN. So you can choose any CIDRs you want for any VPCs, or anything you want to set up there. I mean, it's going to be unique to your use case. I'm going to allow Singapore. Notice you do have to specify /32 after these IPs. Allow all traffic. And then finally, I need to be able to SSH into my front end VPN server just to work on it. So I need to specify my desktop public IP for port 22. Best way to figure out what your public IP is, especially if you're being natted, is just type in my IP in Google search engine, and then they'll give it to you right off the bat. There's mine. By the way, don't think about sending any attacks towards my my IP if you get the idea to do that. No, I have faith in you guys. Don't worry. But anyways, my IP changes quite often actually, so I'm not too worried. Okay, so we're good to go. We've allowed port 22 open in our security group to access the server. Let's go ahead and we're going to launch. Oh, we need to adjust our route tables. Well, we need to actually launch our instances first. So let's click on EC2. And I was kind of playing around with some other VPN concepts earlier today. That's why you see terminated instances here. But we're going to launch 2 new instances for this test. Again, we're going to use Amazon Linux 64-bit. A T1 micro is just fine. Next page. We're going to launch this into the VPC we just created. And remember, the .0/24 in my case is this private subnet. And that's what I'm going to go with here for this first instance. I'm going to assign it a private IP as seen in the topology 10.255.0.94. This is the backend instance that I'm configuring. And next page. Storage looks good. I'm going to give it a tag name that we recognize. VPN backend. Click on select existing security group and then the security group that you have prepared for it. In this case, it's VPN backend. Review and launch. Okay, it's just saying I don't have port 22 open in the security group. That's fine because I'm going to access it a different way. We're going to hit continue. And then this just summarizes everything. We hit launch. Choose the key pair that you have prepared for it. If not, you can create a new one here or just choose the existing. I've already got one, so we're good to go there. Okay. So that one's spinning up. Now we're going to launch our front end server. Same thing, Amazon Linux 64-bit, T1 Micro, next page. Go into VPC, and remember the .1.0/24 is my public subnet. I'm going to launch it in that. Let's see what IP I have assigned for this in my topology. It's 10.255.1.50. Okay. Oh. Okay. Storage looks good. Next tag, VPN front end. Select the existing security group, VPN front end. It's got all the rules that we need. Summary looks good. Choose the existing key pair we have for it. And that one is launching as well. Okay, next thing we need to do is we need to associate Elastic IP with this instance, or to those of you that are new to that concept, EIP is actually just a public IP. And I've already allocated one, but if you haven't, you just click on the allocate new address button. It'll give you a public IP, and then you just right click it and associate it with your front end VPN server. Click associate. Alright, we're still waiting for this thing to boot up, I think. So we're going to go back to the VPC console. And we're going to look at route tables. Now you'll notice that you've already got a main routing table for your VPC. This is your main routing table, and that's fine. You basically have two routes, and it's just saying any traffic that is destined for local IP in this VPC, just route it locally. Default traffic should go out the IGW, which is the internet gateway. We want to have a second route table because we're going to use this one for our public subnet, and then we're going to use a second route table for our private subnet because it's going to look different from the public subnet. Okay, by default this is correct. Local or route local traffic locally. We're going to point our default traffic, however, to the VPN server, the front end. So all default traffic is being sent to the VPN server, and from there the VPN server routes it accordingly, whether out to the internet or over a VPN tunnel. Hit yes, create. And then finally here we need to go to the associations tab and associate it with the private subnet we got for it. So we associate that. Okay, and we're going back to our instances page. And it is running. It's running and passing 2 of 2 health checks. Okay, so let me just share a couple of best practices for you. Again, we're just configuring one region, but there's something you should do, or I would recommend you do, when you're configuring multiple regions. Let's say that you like to use PuTTY like I do to log into or open a terminal session with a Linux box. We'll go into PuTTY here, and I've got profiles set up for every region involved here, right? We don't have Virginia yet. We're going to set up a profile for it. So to do that, just type here and save sessions. Type in, well, in this case, we'll call it Virginia VPN. And then you're going to specify the public IP up here. Let's get that. There's a few other things you need to do first before you save this profile. First thing is go under SSH here, then auth, then in this field, you're going to browse for your private key that you use to authenticate with your server. In this case, I have North Virginia. I'm going to open that. Then go up to connection, specify 60 in this top field. That's just going to keep your SSH session alive even if you're idle for a period of time. Alright, next under window and behavior, you're going to give it a title, a window title. I would name it after the region that you're connecting to in this profile. So in this case, it's Virginia. Next, you go to terminal and features. I'm going to check this last box, disable remote controlled window title changing. And then you go back up to session and you can save that profile and then open. You're going to initially get this little warning box. It just says that you've never connected to this host before. That's completely normal. Just hit yes to skip through it. And then we're going to log in with the default username, which is ec2-user. Now keep in mind this is just a base Linux image, so we need to still do yum update and yum install Openswan. Let's go ahead and do that now. I'm going to sudo su, that way you don't have to sudo every command. And then it's just yum update -y yum install Openswan -y. We're going to let that install. Should only take a few seconds. Okay, it's complete with the installation. So let's go ahead and do a couple things right off the bat before we forget to do them, or I forget to do them. First thing is we want to right-click the instance that you're connecting to, the VPN server, and we're going to look for the option that says Change Source and Destination Check. Going to click on that and disable it. Yes, disable. Okay, so that's disabled. Now, next thing we're going to do is tell IPSEC to start up as a service upon boot. So to do that, just type in check config IPSEC on. Okay, and let's see here. Next thing, we want to modify the sysctl file to. Oh, you know what? Let's just go ahead and change to the etc directory, which basically we're going to do most of our configuration changes in anyway. So we're going to change that directory. And then we're going to modify the sysctl file. And we're going to just automatically enable IP forwarding by changing the 0 to a 1. This will turn on IP forwarding as soon as you reboot or instance comes back up from a boot. Okay, and then we're going to actually start modifying the IPSEC config file that we need to do. So let's go ahead and do that now. I'm going to use Vim. You can use any other text editor that you want to use. So just so that the actual configurations that are active stand out, I'm going to use Vim. It's ipsec.conf. Okay. And I'm not going to get into all this stuff too much as far as what it does. There's only, in this scenario, only a few things that are important to us. So right off the bat, let's just go ahead and comment out the OE directive there. Virtual private. Now this is a global directive that specifies all of the subnets that are allowed over your tunnel. Okay, so you're going to specify all of your VPC CIDRs from the different regions on one line, basically. So you have 192.168/16. You have 172.168/16. You have 10.0/16 and 10.255/16. So we're going to specify that. And the syntax that you use is percentage V as in Victor 4 : and then the subnet. So we'll just start with the 192/16. You separate subnets by comma, 172 168.0.0/16. I can actually summarize the two 10 addresses here into 1/8, so I'll go ahead and do that. Oops. I knew it. It's really easy to overlook. Percentage Victor 4 : there we go. Percentage Victor 4 : and 10.0.0.0/8. Now you might say, well, you know, I don't want, you know, some of my smaller subnets to access other resources over the tunnels. You're going to have to restrict that more by, you know, you could do it by IP tables on the instances. It's probably easier to restrict it in the security groups on those particular regions and in those particular VPCs. I might get into that a little bit later, but for now we'll just get on with the IPSEC config. In theory, if you wanted to, you could include another directory which would hold your IPSEC config file, but I'm just going to leave that commented out. I don't really see the point. I don't know why I would want to open up multiple files to get one job done. So, all right, so I've already got, again, for the sake, you know, because our video is a bit constrained as far as time, I've already typed a lot of this stuff out, but we'll go through it and talk about it here. I'm just going to paste it in to start with. This is basically the configuration, the unique configuration for that unique connection. So in this case, I'm setting up my first connection from Virginia to Ireland, okay? So these are the directives for that one tunnel, or two tunnels actually, but connection as a whole. The connection, the directives for each connection are signaled by the word CONN, right? So that's how the system knows you're talking about a new connection. And you'll see what, you know, you start off a new connection configuration by that word followed by the directives, and that way you can have multiple connections. So let me just adjust some things here. Make sure they're correct. Yeah, I need to just update this a bit. Okay, so left, the word left in Openswan actually means local, or I think of it as the word local, right? So left indicates the local machine that you're working on. So left is the local private IP of the machine you're working on. Left ID is the public IP of the local machine you're working on. Left subnet is the local subnet that the VPN server that you're working on is routing for. Right, I think of it as remote, right? This is how I keep this all separated in my own mind. Right is the public IP of the remote machine you're trying to connect to. Right subnet is the remote subnet that it's routing for. Now, of course, when you're on the remote machine, making configurations for the other side, right becomes left and left becomes right. Now, I'll just give you an example of what I'm talking about there in a second. And then finally, these last three lines are just the encryption and algorithm used to negotiate IKE and IPSEC, phase 1 and phase 2. We're using a pretty strong encryption method here. So we'll go ahead and leave that for now. And again, I'm going to include all this information in the description so you can kind of get a better idea, but I'm moving through it kind of quickly here. So we're going to save it. This thing always gets in my way. It's my video recorder. All right, next thing we need to do is update our IPSEC secrets file. This is where our pre-shared key files are found. Let me just... I don't know if I spelled that right. What am I missing? There's usually already something in there. No, I guess not. Okay, well, anyways, so the format that you use to specify a pre-shared key between two endpoints, again, we're connecting from Virginia to Ireland. You're going to specify the public IP of the remote machine first, or or I'm sorry, the local machine first. So left, public IP, then the space, and then the public IP of the remote or the right machine, colon, capital PSK, quotation, and then whatever you want your pre-share key to be. We'll just say my password. Now, of course, you want this to be a lot more complex in a production environment, but this will work for our testing purposes. Okay. And let's see here. What do we need to do? We want to go ahead and jump over there to Ireland and make sure it looks correct real quick. I believe I already got it set up correctly, but I get a feeling that something's changed since the last time I've checked it. Up. Sorry guys, I'm a little out of it today. We might as well take advantage of this while we're in this terminal. You'll notice here how I've specified, this is what it looks like to have multiple connections, right? So, you know, I've got a connection between Ireland and Sydney, Ireland and Singapore, Ireland and Virginia. And so you'll see, you know, an individual connection for each of those regions. Now I'm just checking the connection with Virginia to make sure everything looks correct on this side. And it appears to be so. Let me just make sure pre-share key looks correct. Okay, and this is the other thing. You'll notice that there's 3 different lines here with pre-share keys. These are representing each of the connections to the different regions. I would recommend using a different pre-share key, obviously, for each region, just for security purposes, but I've simplified it by using the same for each connection just during our test here. So that is it correct. That's my password. That looks good. Let's go back over here to Virginia. And we'll go ahead and start up the service. To start it up, just type in service IPSEC start. Alrighty, and it's starting up. And let me just kind of minimize this for a second so we can look at the topology in the background. Again, I'm trying to connect from here to here. And I'm going to try to ping the internal IP on the other side there. So let's do that now. You know what? I just realized that I had forgotten to apply the sysctl file after I changed it. So let me do that now. So just sysctl and -p sysctl. Oh. What is the... I'm fat fingering everything today. Alright, we've applied it now. So let me just stop and start it one more time. Alright, and I'm going to try to ping the internal IP of the Ireland server here. And it's not working for some reason. I tell you what, I'm going to go ahead and pause this video and I'll be right back as soon as I figure out what I did wrong. Alright guys, I'm back, and you probably already know this, you probably caught it yourself, but I figured out what it was. I had modified a file called IPEC.secrets instead of IPSEC.secrets. I don't know what's wrong with me today. I'm having a focusing issue, you know. But anyways, you probably saw that an hour back and like, okay, that guy's going to have to come back to this. But anyway, so we fixed that now. Let's see if we can actually bring the service up and ping across the tunnel. So it's going to be service IPSEC start. And you can actually verify the status of your tunnels by typing in service IPSEC status. And we show one tunnel up. It'll probably show 2 tunnels up as soon as we start the ping. And we're going to ping again from Virginia here to the internal IP there. So let's try that. .1.136. And we're getting a reply. So now let's try the ping from the VPN server to the backend server on the Ireland side. Let's 0.27. And we're getting a reply back from that. That's good. So I'm going to go ahead and stop that. Now here's the million-dollar question. Can I ping from this backend server all the way to this backend server? The way I like to test that is just SSH straight from the VPN server to the backend server. And let's see, we're logging into. I'm using my FTP server or FTP client here to upload the private PIM file there, so that I can SSH into the backend server. And let's see here, got North Virginia PIM. Upload that. I must have done it twice there. Whatever. Okay. Back to this. Let's see if it's in the file. Or and there it is. So let's go ahead and SSH into the back end. EC2 user at 255 or 10.255.0.94. Yes, I want to continue. All right, I'm on the backend server now. Let's see if I can ping from this server to that server. Here we go. Ping 192.168.0.27. And I'm getting a reply back. That's all well and good. Let's see what it looks like to set up another configuration here. Or we're going to actually go and add the other configurations for the other two regions. And I'm going to move through this kind of quickly because we're running out of time. So let's see. Vim, IPSEC, not IPEC, but IPSEC. Alright, I figured out what it was. I'm still on the backend instance here. It's been a long day. Alright, let's try that again. There it is. And you just add these other connections here. We're just going to modify this real quick. So left remains left, however, the right public IP is different. For already got Ireland, we're going to now set it up for Singapore. And it's actually 172. See how nice it is to have everything in one spot here, so you can just reference it right there. Bam. And then we're just going to change this title to Singapore. Alright. And we got a final connection here that we're setting up, and it's going to be to Sydney. And left remains left. Sydney public IP is this right here. And that's going to be right. Right subnet is 10.00. Everything looks correct. Paste that bad boy in there. Okay, and of course we got to do this secrets file now. Okay, so This remains the same. And we're just going to go down the line. Really? Come on. Okay. And then finally we're going to add Singapore. Why does it keep doing that? And that's pretty much all there is to this. So now we just start IPSEC back up, or stop it first and then start it back up. And then you can look at the status. What? I don't believe that. Let's try to ping the other side real quick. Maybe we need to ping across to bring up the tunnel. I'm going to try to ping the 10.0.1.11. Let me check the configuration on the other side here. Been having a rough day trying to get this thing up, I tell you. Going into Etsy, Vim, IPSEC, CONF. Oh, we gotta go sudo. That's weird. Why would I do that? I don't know. That'll still work. There's /16s nonetheless. So let me just make sure that the connection to Virginia looks correct. And it looks correct. So all right, I'm going to pause the video once again, try to figure out what's going on. I'll be right back. All right, guys, I'm back. I think I found the problem here, and I just wanted to go ahead and show you what caused this, and just show you how easy it is to overlook. There's so many little details here. So the left IP, the private IP of the instance I'm working on, should be 10.255.1.150. It was 1.150, like this. This is incorrect. So I'm going to save that now and do a service IPSEC stop, start, and just check the status again. Oh, we're looking better at least. Let's try to ping across now. 10.0.1.11. Alright, we're getting a response now. Alright, so we just pinged from Virginia there, and then let's just make sure we can still ping to Ireland, and then we're going to ping here as well. So now we've successfully pinged here. We're going to ping to Ireland. I tell you what, I'm going to go ahead and SSH into the backend server. Now, of course, to be completely thorough, and we don't have time to check everything, you would want to check from every backend instance across the tunnels to every other backend instance. Make sure you have complete throughput, but we don't have time in this video to do that. So let me just show you what you would do. You're going to SSH into the backend instance. Let's see here, and just go into my home folder there. SSH-I-in EC2 user at 10.255.0.94. Logging in. Alright, so first we're pinging to the 192 address, the backend server over there. And we're getting a reply. Next, we're going to ping the backend server here. And we're getting a reply there. And then finally, we're pinging from this backend server to this backend server. And we're getting a reply there. Great. So now we've literally got a connection, a unique connection to every other region. And more than likely, if you test it from any machine here in this topology, you're going to be able to hit the other machines. Again, you can restrict resources by use of security groups or IP tables. And I might cover that in a different video. We don't really have time to do it this time. Last step, we want to also turn this server into a NAT server so that your backend instances can access the internet outbound. Basically, the command for this is the IP tables command here. And again, I'll include this in the description. You just adjust it for your use case, but I'm just going to copy this here and paste it. Basically just sets up IP tables post routing for, NAT, for the private subnet. So hit enter. Oh. Gotta exit the backend server. One of these days I'll learn, I promise. So I'm gonna go ahead and apply this to the VPN server. Okay, I just want to make sure real quick I can ping from the VPN server to the outside world. I can hit Google. I'm going to SSH back into the backend server now and test Google. And I can hit it as well. So I have outbound internet access from a private instance that's only given a private IP. This does not work when you try to access the backend server inbound. It doesn't work like that. And that's probably a good thing. It adds a level of security there. Okay, so that's pretty much it. I hope that this video has helped you. And if you have any questions, just feel free to drop a comment and I'll try to answer. Thanks a lot. Bye-bye.